All right, everybody, welcome back. Apologia, Physical Science, Week 2, Day 1. Today we're going to be covering textbook pages 17 through 24, notebook pages, only page 32. All right, measuring and manipulating data. One more time from the beginning. What is the first step of the scientific process? Observation, gathering information using senses or with the aid of instruments. So again, we've talked about qualitative versus quantitative observations. Quantitative observations involve taking measurements. Measurements always have two parts, a number followed by a unit. So again, quantitative observations involve taking measurements, and they always have two parts, a number followed by a unit. The units we use are just as important as the numbers that we get. In science, and truly in life, numbers mean nothing unless there are units attached to them. All right, to make life easier, to share information with scientists all over the world, we have agreed upon an international system of units. It is called the SI, System International. The modern metric system, SI, contains the units that scientists all over the world have agreed to use. Okay. The metric system is a system of measuring. SI has only 3 base units. For length, when you are referring to length, it will always be the meter. So again, the base unit of length is meter. Mass, kilogram. Time, second. So again, when we're talking about length, it'll be in meters, or we can convert it to meters. Mass, the standard is kilograms, and time will be seconds. All right, now there's a bunch of common prefixes used with these SI units. There's a trillion, which is a tera. Then there's a billion, which is a giga. Then there's a million, which is mega. Then there's a kilo, which is 1,000. Then there's a hecto, which is 100. And honestly, no one really uses hecto. But that would, if you were talking about 100, you could use hecto. Deca is 10, and again, not really commonly used. Then you have your base unit. Then when you want to go smaller, you have your deci, which is a tenth. Your centi, hundredth, milli, thousandth, micro, millionth, nano, billionth, pico, trillionth. So those are the common prefixes used with our SI units. The metric system is way more logical and versatile than our English system. So much easier to use. Most countries in the world use the metric system, really, except for us. We're the only ones that haven't adopted it. All right, so the standard for mass. First of all, what is mass? Mass is the amount of matter something has. The unit for mass is the gram. Length. The unit for length is the meter. Volume. Volume is how much space an object occupies. Now there's 2 standards depending on whether or not it's a solid or it's a liquid. So for volume, the unit of liquid is the liter. The unit for a solid volume is a cubic meter. Time, this is easy for us. The unit for length is the second. Temperature. The unit for temperature measurements is degrees Celsius. Ice melts at 0 degrees. Water boils at 100 degrees. And then we also have the unit for thermal energy, which is Kelvin, not degrees Kelvin, just Kelvin. We're really not going to talk too much about that this course. We're going to really be using Celsius. All right, so why are units important? Numbers really without units are meaningless. For example, congratulations, you won 100. 100 what? $100, $100,000, 100 cats, 100 apples, 100 what? What is the base metric unit in English unit for length? That would be meter for metric and foot for English. The base metric unit in English unit for mass would be kilogram and slug. For mass, they go back and forth between kilogram and gram. I will accept either happily. So again, it can be gram and slug or kilogram and slug. Time, second and second. Volume, liter and gallon for the English unit. List the number, prefix, and symbol for the following metric quantities. 1,000 equals 1 with 3 zeros. Kilo is the prefix and a little small k is the symbol. Hundredth is 0.01. The prefix is centi and it's a small c. Thousandth is 0.001. Milli is the prefix and m is the symbol. What did the text say was an interesting fact about volume? Well, the volume of 1 cubic centimeter is equal to the volume of 1 milliliter. That might not seem overly interesting to you, but it will when we start to have to make some different conversions. That's just going to have to be something you sort of remember. What are the different temperature scales? Which one are we going to use for this course? Well, as I mentioned in the previous slide, we're going to use degrees Celsius. The different temperature scales are, we have Fahrenheit and Celsius. And then the unit for thermal energy is Kelvin. And again, we're not going to really talk about Kelvin this course. We're going to use degrees Celsius when we are talking about temperature. Alrighty, thanks.